Good morning, everybody. Happy Monday. Hope you're doing well. Oh, that's the wrong screen. This one here. Yeah. Alrighty. We've got a couple things today. We are going to talk about Project 3. Oh, thank you so much, Fallen. Hydration. I got my coffee. Hope you do too. We're going to talk about Project 3. We'll get into arrays, and then we'll talk about our last individual project for the class. Posture check. Thank you so much. Yeah, you're looking out for me. You know, actually, my back was sore yesterday. I don't know, like, sometimes you get those, like, cricks in it. And I asked my wife if she would, like, walk along my back. I don't know if you've ever had anybody do that. They, like, try and, like, bounce just a little bit to kind of crack your back. And my kids were like, "What are you doing? What are you doing?" Apparently, they hadn't seen us do that before. Just, okay. I don't know. I feel like people used to do that all the time. Walk on your back and crack it, and you get those real big cracks, like you're like, oh, but it feels really good. So yeah, I gotta make sure I have good posture here. Thank you. All right, yep. So arrays, and then inheritance the next week, and then GUI applications. We'll cover some of the basics here. We're not going to do everything in Chapter 12 and Chapter 13, but we'll get there. We got a little bit of time for some miscellaneous topics. I want to talk about exceptions because it bothers me we don't do that earlier. And then the last week of April is set aside just for you to work on your final project. I can answer any questions you might have. Usually we do this in pairs, so that's your time to meet your partner and work on that together. Pairs are optional. And then the plan is, although it has been synchronous optional, if you can make it on 5/3, we'll try and get together and present our final projects and show off what we did to each other. If you can't make it on 5/3 in the morning, then I can arrange to meet with you some other time. You can present just to me, or we can do some sort of recording. So we'll talk more about that as we get close. But if you can keep that time set aside, great. If not, we'll manage, but that's the plan. So we are cruising along. This is week 11. Wow. And it is officially spring, right? Happy spring. Hope you had a chance to play outside. Get some good sunshine. I don't think I got a sunburn, which is nice, but I was outside quite a bit with the kids. They were having fun. All right, so should we talk about Project 3 first? Net beans, yes please. All right, let's get that to load. Come on. Come on, come on. Let's see. Excuse me. Knows how slow it is. Come on. Here, well, okay, while that loads, here then. Pull this up. So, yeah, unfortunately, I had to break up with my gym. And, quitting the gym is always the hardest thing, but, the gym and I just weren't working out. Maybe I wasn't working out. All right. I thought that was a good one. All right, what else? I got one more here. Oh yeah, so I was trying to find a good place to buy just some handguns, and my friend recommended that I go see this T-Rex down the street. And I said, wait, what? See who down the street? He said a T-Rex. said, well, why would I go see him for handguns? And he said, oh, he's a small arms dealer. That's the wrong project 3. All right. There we go. Here's project 3. So we had started off with a couple methods here. Right? Because I talked about how, not always the case, but what we're going for here is that main really just calls methods. Doesn't do a whole lot other than that. And then we're going to kind of take a big problem and break it into smaller problems and smaller problems and smaller problems. So we looked at a couple of those for play mode, or I'm sorry, create mode, right? So, okay, sure, if we're going to create mode, we create the game introduction file, we make the command files, and we make the escape word file. Those are the things we needed to do for create mode. Let's see, pull that assignment here. Okay, we got a rubric for it. So main only has code for calling other methods. That's pretty much what we had there, right? And then create mode. We make a game introduction file. We make command files until the user is all done entering them. They ask if the command would wound. Oh, not will would. That should be wound. Sorry for the typo there. And it's updated appropriately. The escape word file is created. Okay. So those are the pieces that we're doing. Okay, we can do all that. Let me shrink that down a little bit. So to create the game introduction file. Whew. Yeah, not had enough coffee yet, sorry. So we're going to make a file called gameintroduction.txt, ask the user to enter the game introduction, and write the contents. Okay. So if we're going to be talking to the user, we need to make a scanner. Remember we talked a little bit about we could make it in every method, or we could make it once as a static attribute. Either ways, I'm okay with. We haven't really talked a whole lot about making it as a static attribute, but if you wanted to, you could. So we could say, hey, up here we could have a static scanner keyboard, and then in main, we need to tell Java what a scanner is. Yes, please import that one. And then in main, we could say keyboard equals new scanner given system in. We could do it up here if we wanted, and then we've got a scanner we can use everywhere else inside of our code. Then I can just say down here, so keyboard dot next line if I wanted to get some input. So we'll tell them, hey, please enter the game introduction. And then a string like for intro is keyboard.nextLine. We've got that. Now we need to make a file. So we use print writer, not printer writer, print writer. I don't know, file writer or something equals a new print writer. Given, and we want to call this game introduction.txt. And now it's going to complain about a print writer. Sure, let's import print writer, and then it's going to complain that we might raise an exception, throw an exception. Yep, we're going to add this throws clause. We know we might crash. We're just going to pass the buck. We're okay with that. Okay. Now I might want to make this a variable here, right? Because that's probably the cleaner thing to do. So I can have a variable defined, static string game introduction file equals that, and that way I can use that everywhere else. Again, not necessary, but this is nice that if I'm going to use this variable more than once, I can just use it by name here. It's a good habit, right, to not have just random numbers or strings out here if we can help it. Okay, we'll take a file writer. So we've opened the file. Now we're going to write to the file, and then we're going to close the file. We're going to do our 3 things. We're going to print line, and we want to print our intro. And then we close it. File writer not close. Always make sure you close. Okay, so ask them what the introduction is, get their input, open up the file, write the file, and close the file. Good so far. Now, our create mode's yelling at us because we aren't passing the buck. Right? This might throw an exception, so we need to tell Java, yeah, we're okay with that. You even could also throw the exception, pass the buck will crash. Again, we'll get to exceptions. I want to talk about that a little bit at our Miscellaneous Topics week. We'll cover it in 2151 if you do continue on. By the way, summer registration is open, in case you were curious. You can register for summer classes, and they are filling up, not super quick, but they are filling up. So let me take a look. If you're curious in taking any of the next level CIS classes, take a peek real quick. We look for like all CIS classes here. Right. So if you're looking for like 2151, that's the available, right? Okay, so still 19 seats left. That's pretty good. We still got room in 2151 over the summer. If you wanted to take 2151, if you wanted to take data structures, there's 15 left. If you wanted to take the PHP class, there's 12 left. And you might have noticed my name's on all of those. So if you're taking any of the 200 level or 2000 level courses, I hope this format works for you, and I hope this works out. You're going to take C++, you get Dr. Baugh. He's amazing, super smart, real nice guy. You'll love taking classes with him. And then I don't know what other classes you folks are going to take. So let me know. I'll tell you what I can about it. But we've got the schedule up there. Registration is open. I assume everyone takes software engineering classes because that's what I'm into, but I know not everyone does. Right. What do we have? What else? Yeah, that's it for summer. And don't forget, there's a summer scholarship you can apply for as well. Let's see, summer scholarship. I heard what this one is. Just heard about it. Summer Momentum Scholarship. Here we go. This is other good news. I thought this one was pretty cool. So you have until April to apply for it, which is nice. You have a little bit of time. What was the deal? So if you've had 18 to 23 credits, so if you were here for fall and winter, then they'll pay for up to 3 credits for you. If you've had 24 or more, so if you were full-time fall or winter, or if this is, between fall and winter. So if you were part-time fall and winter, or if you were full-time fall and winter, you can get up to 6 credits, part-time up to 3 credits paid for in your plan of study. So you don't go take a fun class out of this one. It's got to be in your degree program plan of study, unfortunately. But definitely worth applying for. Free money if you qualify. Right, you just fill out that general application. It should recommend it for you. Yeah. So cool. Tell your friends about this one. I'll post this in our Discord here, so don't forget. For the Summer Momentum Scholarship. April 23rd. Awesome. Okay. Back to the project. Sorry, we got off on that tangent somehow. I'm gonna need more coffee. Okay, to create game files, the command files, right? As long as they haven't entered, what should our escape word be? So whatever we want to tell them to enter a command, or this message to stop entering commands. How about stop create mode? And we can even have spaces in there, right? We can look for spaces. Okay? So we'll ask them. Right? So don't create the name with the file with the sentinel name value. We should ask them. So enter the name of a command for the game, or and I'm going to put this in quotes, stop create mode to be done entering commands. That's a little long here, so let's just knock that down a line. Okay. Cool. So we're going to do that. But we don't want to do it if they enter that. So if, and again, I feel a little bad having to repeat this. We've got some options, but really we just have to repeat it here. Make sure they did not enter that message. If they did not enter that message, create the command file. Right. But we should also probably set file name, right? So file name equals keyboard.nextLine. Okay. Awesome. Then what we're going to do here, because I want these to be files, I'm going to take the file name and I'm going to add to it .txt. Right? Because they're probably not going to type in go-up.txt or fall-asleep.txt or whatever. They're just going to enter the command like we asked them to. So I'm going to add in the .txt myself before we call create command file. We could do it in here as well. Either way is okay. But this will make it a little easier just for us to open the files. Again, files don't have to have extensions. It just makes it easier for us to open them in Windows. Okay, so they keep on doing that until they enter this create command mode, and then we're done with our method. If we do create the command file, great. So we need to ask the player if it will wound them. So maybe we don't actually want to add the txt yet. Maybe we do. That's okay. Will this wound the player? And again, I'm going to suggest a y or n here, just to make this a little bit easier for the user. And then we'll have a string for wounds player. I don't know, sure. It's keyboard.nextLine. We'll get their input. If it is, right, so if wounded player equals ignore case, wounds player, there we go, wounds player equals ignore case. If it equals a y, then I need to write wounded to the file. Otherwise, write a blank line. So I'm going to need a file. Okay, so let's make a file. We need a print writer, not printer. I always want to say printer writer. Print writer, file writer, equals a new print writer, given the file name. Remember, file name was passed to us as the argument here. He said, here's the name of the file. I already added the txt, so we're happy. And yes, we need to add our throws clause because bad things could happen. Yes, we need to add the throws clause because bad things could happen. Right? We're just going to pass the buck. So if it wounds the player, we'll take our file writer and we're going to print line wounded or something. Right? That'll be the first line of the file. Okay, give that a little format. Otherwise, we're just going to write an empty line. Right? Print out an empty line. Okay? Then we need to ask what happens when they do that thing. Oops. Format. There we go. Yes, out. What happens when the player does this? I don't know, or whatever we want to say, right? Okay, and we'll get that message, a string description or something. Description equals keyboard.nextLine. And then we'll write to our file writer. File writer, print line, the description. And then we'll close our file writer. Right, we opened it, we wrote to it, and we're going to close it. Nope, close. There we go. Sometimes the type ahead doesn't work well for me. Right, that's the file. Okay, so when we pass them a file name, we'll ask if it wounds the player. We'll get their wounded status. We'll create the file. We'll either write wounded or not. It's an empty line, and then we'll get the description. What happens when the player does this, or describe. We'll say describe what happens when the player does this command. I don't know, sure. That's probably fine, okay? And then it'll make the command file. When that's done, we'll come back up, we'll ask them for another command, or stop create mode, enter another command, or stop create mode, on and on and on, until they're done with all of that, and then we can make our escape word file. We'll ask them for enter the secret escape word. a secret escape word that ends the game. Okay, we'll have a string for escape word, keyboard.next line. We get their input, next line, and then we need to open the file, write to the file, and close the file. So escape word txt. So again, I'm going to do this thing where I make a static variable for it. Static string escape word file, escape word txt. I'll put some quotes in there. Go back down to where we were. Okay. So make a print writer. File writer equals a new print writer, given the escape word file. Escape word file. Okay. Yes, we might throw an exception. We're happy about that. And then we write to the file. So file writer dot print line, the escape word. And then we close it. File writer dot close. Okay, that's it for create mode. Let's try it, right? Let's see if this part works. Oh, this one will also pass the buck. Yes, Maine, you can crash too. Thanks. Oh, ask for player create mode. We should probably make that work. So let's enter to create or play the game. And I'm just going to return keyboard.next line. No, this should make sure we string, I don't know, choice is that, and we'll say while choice does dot equals ignore case play and choice equals ignore case create. And we want to say while it does not equal play and it does not equal create. We want to keep on doing this here. Choice is keyboard.next line. Right? We'll keep them inside of this loop until they give us what we expect, either play or create. Right, why not? We could do I don't think I asked for this validation loop, but why not? We could do a validation loop. We know how to do those, right? We like loops. Do you guys like loops? We like loops. Okay, so if it's not play and it's not create. So if they enter apple, not play is true, not create is true. If they enter play, not play is false, so the loop will stop. Right? If either one of them becomes false because we're anding, the whole thing is false and the loop stops. So you have to be a little bit careful with these. Sometimes you think it might be an or, and sometimes you might think it's an and we want to try it. You know, give it a couple values and see, does it behave the way we expect? Okay, just got to be careful with that. Okay, and then when we're done, we return choice. Okay, so now we should be able to do create mode and make a bunch of files. Play mode will do nothing. Right? We've got nothing here yet. All we have is the create mode stuff, but that's okay. Let's try it and see if we get any files. Let me pull this up a little bit here. How are we doing so far? Folks okay? No surprises? Okay, let's create. All right, enter the game introduction. Welcome to the most boring game ever. Enter the name of a command. Sleep. No. You sleep. Enter the name of a command. Jump. Yes, jumping wounds the player. You jump and land wrong and sprain your ankle. Enter the name of a command. Stop create mode. Enter the secret escape word. Get me out of here. Okay, so we should see a couple files. So again, we can go to this file view if you want, or you can go open it up in Windows Explorer. I like this file view because then we can go see them real quick. So we see escape word is get me out of here. We see game introduction. Welcome to the most boring game ever. We see jump. which will wound the player. And you jump and land wrong and sprain your ankle. And we see sleep, you sleep. Okay, so we can see the files over there pretty nicely. So we know we made a bunch of files, and we can open them up. We can look at them. It's looking pretty good so far. What do you folks think? Do we do everything we need for create mode? Okay, should we do play mode? Okay, let's see. So what would play mode do then? So maybe play mode will, I don't know, read game introduction. And then maybe play mode will get the escape word. And that probably needs to return a value. So we're going to have a string for escape word. Will be whatever we get back from get escape word here. Right? So we'll go read the file, and we're going to save that as the escape word. Whatever it returns to us, we'll save that. And then we're going to loop, right? While, I guess we'll have a string for command. Command is nothing. And while command.equals ignore case. String, thank you. String equals ignore case, the escape word. While it does not equal that, let's keep them in the loop. Okay, so if it doesn't equal the escape word, let's see if there's a file with that name. Right, so then we'll, I don't know, check for, what do we want to do here? We could say check for file. I don't know, we could, oh, okay, so we check to see if there's a command first. So we're going to do this inside the loop. So we should ask them what do they want to do, right? So what do you want to do? Do you want to do? Right, this is the start of the game, right? We gave the game introduction, and then we're going to start up our loop. So ask them what they want to do, and then we'll have command is keyboard.nextLine. You can enter a command. Then we need to check for file with that name. Right? So we'll, I don't know, I guess we should check to make sure, again, it's not the escape word one last time. So if it's not the escape word, then we can keep going. If it is the escape word, we just don't want to do anything, and then the while loop will stop. And we can say, I don't know, thanks playing our terrible game. Right, once they enter the escape word, they get to end. So we could give them that message if we wanted, sure. If it's not the escape word, then we'll go do the thing. Oh, check for file. We can say, what should we do there? We can say if check for command file, given the command plus .txt again, we can add that there. And if that's true, we do something. Else we'll say you can't do that. And so if it's there, we're just going to read the contents out. So I don't know. There's not a whole lot else that's going to happen there. This one's a little bit harder to break, isn't it? Into all those methods. Let's see. No, we can do this. Here we go. We'll say if it's not, I don't know what, if not command file exists, then we'll tell them you can't do that. There, I like that. That way we don't have to have an else here. Because if it is true, we can, inside this method, we can go do all the other stuff here. I like that. That'll be fun. All right, so I think we broke it down then. So this command file exists. We'll go and check to see if it's wounded, and then we'll print the description for them. Right? And then should be pretty good. That's not too bad for game mode then. Play mode. All right, so we'll go read the game introduction. So let's go make a method. Create a method. Yes, please. Okay, so I have read a game introduction. You can navigate all your methods over here in the bottom left. It's really nice. So we're going to go read the game introduction. Sure. So we need to make a file. File intro equals new file, given, and this is what the game introduction file is, the file name here. And then yes, we want to import file. Okay, and then we're going to pass that to scanner. So this is my file reader equals a new scanner, given the intro file. And remember to read a file from beginning to end. We probably know there's only one line, but if we wanted to, we could do it inside of a loop. Either way is okay. And yeah, we want to add our throws exception. We could say while file reader dot has next. This is the way to like read all the contents out. Usually we just keep looping until there's nothing else left. We'll say, we'll just print out. Sure, why not? There's nothing else for us to do. File reader dot next line. Print the contents. And when we're done, close the file reader, right? Open it, read it, and close it. Close. Cool, so now you've read the game introduction to them. And this loop may be a little silly because we know it only had one line, but why not? Okay, so we did that one. Now we need to get the escape word. Oh, we need to tell Java, yeah, we might throw an exception as well. We'll add our throws clause. Okay, we'll get the escape word. So make a method. Create a method for it. The get escape word. Awesome. Okay, so we need a file. This is the escape word. File equals new file, given the escape word file. Oops, probably can't do that. I'll just call it the escape word. Sure. There we go. And then a scanner, file reader equals new scanner, given the escape word file, or the escape word, which we created with the file name. I don't know, maybe we should have. Okay, I'm going to rename this. Don't do it by hand either. Right click, refactor, rename, right? Use the tools. We'll call this the escape word file name. And it's going to go fix that everywhere. And then I can call this one the file here. That makes me happier. Okay. So we can go get the contents back out. Oh, we got to add our throws exception here. And we can have a string for the escape word. Here's my file reader. Next line. Get the line out. File reader dot close. Close the file. And then return the escape word. Right? Open the file. I'm sorry, create the file. Open it, read it, close it, and then return the method, or return the word. So now we can set escape word up here in our play mode. Okay, or we can just keep on looping until they've entered the escape word. So we'll get their command. If it's not the escape word, check to see if it's a command. So let's see if the command file exists. I don't know, or check for command file. I don't know if. Sure. Let's add that method. Command file exists. Given a string for the command file. Maybe we should call this. Okay, I'm not happy with this one. Let's do this refactor, rename. We'll just say try command. I like that. And then I don't even want this if block. I'm going to do that inside the command. Okay. There we go. We're just going to try the command. I like that better. So as long as it's not the escape word, let's try it. And try command can figure out whether or not it existed or not. We'll go to try command. Okay? So make a file. File command file equals a new file given the string here. Ah, that's ugly. This should be the command. There we go. String command. Okay, and now we can check if command file exists. I use this little exist method to see whether or not, no, exists, please, exists. If it exists, we can do the command. If it doesn't exist, they can't do that. Print out, you can't do that. So if it does exist, great. Now we can hand it to scanner. File reader equals a new scanner, given the command file. Okay, and yes, we might throw an exception. That's fine. Oh, Oh, and this one doesn't need to return a Boolean anymore. This can just be a void method, right? Because we don't need to tell them true or false it worked or not. Okay, so great, we'll have the file and we'll get a wounded status. So this is wounds player, wounds player, or wounds player line. Sure, why not? We'll call that the line. My file reader, done, next line. And this is either going to say wounded or it's going to be blank. So if it is wounded, we need to do something special. If it's not wounded, we don't do the special thing. Okay, but either way, then we still need the description. So we'll have a string for description equals my file reader dot next line. So the first line, because I know I have two lines, I know I have the wounded line or not, and then I have the description line or not. So we have both here. Okay, and then we'll print out the, how about we print out the description, and then if wounds player dot equals ignore case is wounded, then we need to tell them they have to sleep, right? You are wounded and must sleep. And then we're going to wait until they enter the word sleep, right? So then we'll do this in a, I don't know, we'll have a string for command is nothing, and while command dot equals ignore case equals ignore case sleep, while it doesn't equal sleep, let's keep them inside the loop. Have keyboard, or no, command, it's keyboard dot next line. Sure, throw this in here. Oh, we already had a command. Okay, that's oh, sleep command. Sure, why not? We'll call it sleep command. Okay, so as long as they haven't entered sleep, just keep on telling them they're wounded and they have to sleep. Right? This is the idea that once they are wounded in play mode, force them to sleep before they're allowed to do anything else. Okay, so if the file wounds them, just keep them inside a loop and say the only thing you can do is sleep. The only thing you can do is sleep. Okay, before we let them get back. Or we could have put it in the rest of our options. Either way is okay. Let's see. So play mode reads the game introduction, displays the contents. It loops until they enter the escape word. If the command doesn't match, tell them they can't do it. If it wounds a player, make them do that. And if the command does exist, display the contents. I think that was it then, right? So if they are wounded, make them sleep. Otherwise, that's it, right? We printed out the description. So we try the command and keep them in the loop if they get wounded, and that was it. Oh, we got an extra curly brace down here. That's weird. Okay, give it a little format. I think that's it. And we just keep on trying commands inside of our game mode, our play mode, right? We'll read the game introduction, we'll get the escape word, and then as long as they haven't entered the escape word, we'll keep trying commands. Keep trying commands, keep trying commands. And then once they enter the escape word, thanks for playing, or something, some kind of message. Let's try it. Let's play the game. All right, welcome to the most boring game ever. That was the content of our game introduction. What do we want to do? We want to run. Oh, we can't do that. We want to sleep. We sleep. Jump. Oops, I can't spell. Jump. You jump and land wrong and sprain your ankle. You're wounded and must sleep. I want to jump. You're wounded and must sleep. I want to jump. I want to sleep. Right, what do you want to do? You slept. I guess we could have a message in there if we wanted. Like, you sleep and feel better. I don't know, that I feel a little silly now. Let's see, let's try command. So if they entered sleep, then, I don't know, we'll say you sleep and are miraculously healed. Sure, why not? Just for fun. Again, not required, just having some fun here. I've always been puzzled, like, you know, I get the idea that we need ways to heal players in D&D, but like, you just sleep overnight and you get all your hit points back. You're, you know, can be 1 hit point left, you know, just barely away from death, and all of a sudden 8 hours of sleep and you're like a brand new person. Sure. we have to have some kind of heal mechanics. I get it, but I just, like, really, one night's rest and you're all better? But, okay, sure. Otherwise, the game would just be too slow. You'd have to sleep way too many times in between events. But, all right. Cool. Questions about Project 3? I'll post this to the GitHub here. Give me a second. Let's see. Let's make sure this is 1500. There we go. Should see a couple changes. Oh, I didn't commit chapter 6. I'm sorry, folks. Let me do this. You don't ever need to do separate commits, but it bothers my OCD-ness a little bit here. So this is Project 3. Complete. Man, I forgot to add all that. You guys didn't even tell me. I guess no one went and looked. And then, I guess I should have done this one first. That's okay. I'll do the rest of chapter 6 stuff. Come on. Still thinking hard. There we go. Chapter 6. That's okay, Dmowski. We'll see what went wrong, and you get points according to the rubric, so there's always partial points there. There's the parts you did check off. All right. So let's go back here. Oh, you did get it right? I'm sorry. Or, okay. I think I'm just confused. I need some more coffee here. All right, got those pushed. Awesome. All right. So we're going to talk about arrays and the Arraylist class. I am a huge fan of Arraylists and not arrays, but that's okay. They're both great. And then we're also going to talk about your last individual project, Project 4, which is going to be due on April 5th. So 2 more weeks for that one. So I got lots of questions over the weekend. So, we had time for this one, but we had like break and we had midterms in between and all this stuff. So, it felt like there was a lot of time, and then all of a sudden it was due. So please start this one today. Even, go to study group right after class today at noon and talk with your fellow classmates and our amazing SI about Project 4 and how to get started on it. You will thank yourself, I promise. Right? Go to the study group session, get started on it, because this is the biggest individual project you have, right? Project 4 here. And I'm fond of it because I think it's an interesting kind of project, but I'm a little weird, so that's okay. Maybe what I think is interesting might not be so interesting, but it's a lot of fun. So we're going to use classes, and we're going to use arrays or array lists. Pretty much the array list is what you want to use. Don't do the project with arrays. But you don't know what those are yet, so don't worry about it. So we'll talk about arrays for a little while, and then we'll talk about Project 4, and then you guys will have study group, which you should all go attend, so you can get a head start on Project 4, which will be due on April 5th in 2 weeks. Okay? That'll be our last individual project, and then we'll pick up the final project, which is a GUI application, right? We'll build a graphical user interface we can actually click on instead of having to type stuff in the console, which is amazing, right? To finally get something more interesting. And that will be the final project. We'll have a month to do from 4.5 to 5.3. There's no final exam, right? In lieu of a final exam, we're doing this large final project, which is 25% of your overall score in the class. And if you do well in the final project, what I'm willing to do for you folks is take your final project score, or the percentage score, and use that in place of your worst individual project of 0 through 4. Probably not 0, right? 1 through 4, because everyone did fine on 0. Okay? So if you get 100% on the final project, I'll just give you that 100% on whatever project you did not get 100% on, your lowest scoring, or whichever one would give you the most benefit, I guess, because they're weighted differently. So, man, I guess I have to do more math now. but that's okay. I'll figure it out. Whichever one will be better for you to get a 100% on. Right? And the goal is everyone gets 100% on this final project because we've got a month to do it and build our GUI application. We're going to have lots of time to work on it. You'll have time in the Miscellaneous Topics week. You'll have time in the final project work time week. You'll have SI sessions. You will have whatever else, right? Time to work on it here. So start on project 4 today. Go to the study session in an hour and 10 minutes and get that one done out of the way, and then we can focus on the final project and you guys can finish out the course strong. Okay? All right, so actually before we start in arrays then, we're almost at 11. Why don't we take a couple minutes? I'm going to go refill my coffee cup. We'll come back, we'll talk about arrays, Arraylist. We'll get you everything you need to know to start project 4. And then we'll talk about project 4. We'll come back on Wednesday, we'll finish up arrays, the array lists, and then you guys can go to your study group session on Wednesday and finish up project 4 and be ahead for once. You guys can get your stuff submitted early. I'll be proud. And we can go from there, okay? All right, so why don't we take 10 minutes and we'll come back right at about 11 o'clock or so. We'll jump into some new content. And after I talk for a while, we'll talk about project 4 and how much fun that one's going to be. Okay? I can't hype that one enough. It is super, super exciting to build this project 4 and be able to do math. Everyone loves math, right? Maybe I'm a little weird, but that's okay. All right, let's get this going. We'll go on break. We'll come back in just a minute here. We'll call that 11:02. And we are now EDT. Yay, Eastern Daylight Time. All right, how about I just say Eastern? Eastern Time. Is that just ET? Eastern Time? Sure. Eastern Time. All right, see you folks in a couple minutes. Hey, welcome back, everybody. All right, so let's start up a new project. We can talk about arrays. Chapter 7, arrays. We'll make sure we're in the right folder here, 1500. All right. Here we go. So, one of the things we've done so far, and it's been pretty steady throughout, is we have said that when you have a variable like number, it can store one thing and only one thing, which is true, right? Mostly true, right? This variable can only store one thing. There's a new kind of variable we're going to talk about called an array, or using the array list after we talked about arrays, that lets you kind of break that rule. The rule sort of works, but you have to think about it in a little bit of a different way here. So what happens, right? Not white pad, white board. That was fun. Sometimes you just type the weirdest things. You ever have that happen to you? Let's do this a clear. Oh, it was clear already. Nice. So remember, when we tell Java we want an int, it says, oh, sure, let me go get a chunk of memory out here for you at, say, like x73ba, right? And it stores a chunk of memory. What do we say? Ints, they 4 bytes? I think ints were 4 bytes, right? Let's Google that to be sure. Java int size. I think it's 4 bytes. Yeah, 4 bytes. Okay. So it goes out and says, here's 4 bytes of memory, and you can do all those 0, 1, 0, 1, 0, 1, 0, 1, right? Right, so that's 1 byte, right? 8 bits is 1 byte, and 0, 0, 0, 0, 1, 0, 1, 0, I don't know, sure, there's another one, 0, 1, 1, 1, 1, 0, 0, 1, there's another one, and oh, there's another one. So that's 4 bytes of memory out here. And we have our number. It's stored somewhere here in memory. Okay, that's our one thing. And remember, if you want, because Windows is awesome, you can go to the calculator app and you can put it in programmer mode here. The full screen calculator app just is so weird, but sure, why not? So go to programmer calculator and you can turn on binary here in bin, and you can go to the binary bit entering, right? And you can start entering some values. And not really worth remembering, but it's just fun. So remember, with binary, everything is base 2. So 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, on and on and on and on. So my bits here, right, are 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, on and on and on and on. So that's possibly a 1. This is possibly a 2, a 4, an 8, a 16, a 32, a 64, and a 128. So if all of those bits are on, you add them all together. If it's off, you don't add it. That's how we find our binary numbers. And that's why Java numbers, our integers, can go up to some 2 odd billion, because if you do all the way up, so this is 1 bit, this is 2 bits, that's 3 bits, 4 bits. If you go all the way up to this one here, no, that's, oh, I want my number, oh, there we go, as a decimal. There we go. So the number as a decimal here, 2,147,483,648. 483,648. We need 1 bit here to tell Java that it's positive or negative. So really, we get all of these other bits here can be turned on. Boop, 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 boop. On. Come on, click faster. If this was like a clicking skill game, I would have failed. So that's our max number, right? For Java, our max int. So if you remember, we have this integer dot max int max value here. We can print out. Integer has some cool stuff here. Oh, come on. Please don't compile on save. I don't know why. It's the most obnoxious setting. Run. $2,147,483,647. All right, perfect. That's what I said. Because it needs to have one bit for whether or not it's positive or negative. Remember, because we can also be up to a negative value, up to a positive value. Okay? So one bit there for positive and negative. Am I losing the stream here? No. I think the bit rate's okay. It just looked like it froze on me here. Okay. So we can store one value, right, in 4 bits with a number. Now, what we get to do with an array is we get to cheat. And we tell Java, hey, I want an integer array with these square braces here. We use all sorts of braces. We have parentheses, we have curly braces, and now we're doing square braces. And we'll say, hey, I want 10 integers. And what Java says is, sure, I will go out and find 10 spaces for integers. 5, 6, 7, 8, 9, 10. Each one of these is 4 bytes. 4 bytes, 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 4 bytes. Those are all 4s. 4s, okay? So I can store 10 integers in here. 1, I don't know, 2, 3, I don't know, any numbers we want, right? Sure. Why don't we do some Fibonacci numbers? 1, 1, 2, 3, 5, 8, 13, 21, 30, 34, my goodness, 55. There we go. Don't want to typo that. In a single variable. The trick here is this variable is the size of 10 integers. Right, so this is my numbers. Numbers. So numbers variable is the size of 10 integers, which is super cool. So I can store 10 of the same type here. So arrays can only store values of the same type. Now what we get to do is we can tell Java which one of these we want by using something we call index notation. The index of. So in an array, each of these values has an index. So these are the values here. These are value. This is the size. Right? That's a terrible S. Sorry. Sometimes it's hard to write. And then we have an index. So index here. So with indexes, you always start at 0. Okay? It's going to be obnoxious until you learn to deal with it. So 0 base. We always start with index 0. So index 0 is the first item. And then index 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in an array of size 10, we have indexes 0 through 9. So you never have an index at your size. So no index at size. So the size is always too big. There'll never be an index at your size. Okay, because we start at 0. So 0 through 9 to give me 10 possible values. And the reason why that is, right, what numbers actually stores is the memory address of the first position. So numbers stores x, I don't know, 329b. Sure, something. Okay, so it stores the start. Okay, that's what it does. And then when you ask for an index, it says, oh, okay, well, how big is the thing you're storing? Well, how big is an integer? So when you want to get at an index, it does plus the index times the size. That should be an S, not a Z. Size. So if you want index 0, 0 times whatever is still 0, you're going to get that first location. If you want index 9, it takes 9 times 4 bytes and says, oh, you need to go 36 bytes. So it'll take this memory address, so 329b, plus 36 bytes, and it will give you right here. So you can jump anywhere in your array by index and go get the value at that index instantly. I mean, you do a little bit of arithmetic, but pretty much instantly with what we'll call it. Okay? So arrays are amazing. We love arrays. And you can't see half of those index numbers. Sorry. I forget my camera's there sometimes. So what we're allowed to do is we can store multiple numbers inside an array here. We can have int numbers, right? And we'll say this is an int array numbers equals. Now we have to do some new syntax. So we don't get to say it equals 42 or whatever here, right? Wait, there's a couple ways we do this. Okay? The first way, if you know what values you have, you can use curly braces, and you call this the initializer. 2, 3, 5, 8, 13, 13, 21, 34, 55. Okay? This is the first syntax. So this is the array initializer syntax. So if you know your values, you put them in curly braces, and Java says, oh, sure, I'm happy. I like it. Integer array, so square braces for array, your variable name for it, and all your values. Okay? If you don't have your values, this is just, if you don't have values to initialize, we're going to say, hey, I want an integer array, we'll call, more numbers, equals, and we say a new integer array, and then we have to tell it the size here. So some size needs a size. So in this case, it can count these, and it will plug it in over here. In our case, we could say, hey, I want 10 values here. So more numbers then will have room for 10 values. So this creates size of 10. It's the size 10 here. I don't know, in this case, in this example. Okay? So then what we can do is we can get at those positions. I can say more numbers using the index value. So I say square brace index of. Yep, so you need the data type, and then you need how many. Yep. So what type are we storing a bunch of, and then how many. So more numbers at 0, then we can assign, let's do like powers of 2 here. Boop, 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 boop. And so 1, 2, 3, 4, 5, 6, 7, and 8, and 9. There we go. Got my arrow keys. So we'll go. Oh, let's start with 1, 2, 4, 8, 16, 32, 64. Oops. 128, 256, 512. Sure. So we can get at individual indexes here with this index notation. So to access single value, use the index notation. That's square braces. So variable name, square brace index. So that's array, variable name, square brace index. Okay? The variable name and then the index we want to grab. The other cool thing is we can loop through these really nicely, right? We can say for int index is 0, index is less than, and you always want to go off the length. So numbers.length here. Your array.length here will always tell you how many valid indexes you have. So if I start at 0 and I go up to but not including the length, I'm perfect. Remember, if I have 10 items, my length is 10. I don't have an index 10. I want to stop at index 9, which is my max index. So loop from index 0 to length -1 through, right? Those can give me all the values back out. So I can, I don't know, we'll just print out, say what's there. We'll take my more numbers at index. So index here can be a variable here. And I can just go through and grab every single value, which is really nice. So if we run that, we should get out our 248, 1, 2, 4, 8, 16, 32, 64, on and on and on and on. Right? Looking good so far. So we just loop through using this index notation to get the particular value out. Okay? So arrays can store multiples of a single type. Multiple values of a single type. Usually we want to loop using their length here if we're going to loop from beginning to end of an array and do something with it. Okay, we can initialize it. We can size it this way. Either's fine. The problem we have with arrays is that if I want an 11th thing here in more numbers, I can't do it. More numbers, once you create an array, is fixed in size and we can't change it. We could make a new array if we wanted to, of size 11, and we could copy all of the things out of more numbers into the new array. But that, again, runs into a little bit of trouble. So we have has some issues there. You got to be careful with. Okay? How are you folks feeling so far? Kind of funny. It's a very new thing here. The other thing we can do, when we create this array, this could be a variable name here. Right, so if I want to make a bunch of numbers here, we'll say, let's play a number game, enter a number. And then I'll have an integer for, I don't know, size equals, we need a scanner here, sorry. So scanner keyboard equals a new scanner, given system.in. And size is going to be integer.parseInt given keyboard.nextLine. Yes, we know what a scanner is. Thank you very much. Okay, then I can make another array to play with here. So sure, let's have a integer array of, I don't know, this is users numbers equals a new integer array of size. So size can be a variable here. And then I can say for int index, right, as long as we're less than users numbers length, let's go ask them for a value. Right, so let's say enter a value. Enter a value for index, and I'm going to put the index right in here, like that. Right, and then we'll do the same thing. We'll get their value out. So I'm going to take my user's number at index. I'm going to assign it the value of whatever they give me. Right, so we can use the index notation to get a value or to write a value. Right, so in this case, we were just reading the value and printing it. In this case, we're going to assign to it. So we can change the value at a given index here. With, sure, whatever they give me. So they'll say, how many numbers, or how many numbers should we enter? How many numbers do you want to enter? That's a little long here, but that's probably fine. So I'll bump it down. I'm feeling bad. How many numbers do we want to enter? We'll enter a bunch of numbers. Okay. And we'll go do some stuff. So they'll enter a bunch of numbers, and then we'll say, I don't know, smart computer can figure out the min, max, and average. Okay, why not? So if they enter a bunch of values, right, let's see, can we find the minimum, the maximum, and the average? What do you think? Do you think we could do that? So if they enter a bunch of values, can we find the min, the max, and the average? Being able to loop through the array? Right, just like in English here, before we write any code, what steps do you have to do if I give you a bunch of numbers to find the minimum? Right? So say I give you a bunch of numbers, so like 7 to 21, 35, 15. So what do you do with these numbers to find the minimum? And don't tell me look at them and see which one is smallest. Right? Like, how do we look at them and see which one is the smallest? Right? What's the process that we have to take to do that? Sorry, my allergies are driving me crazy here. Spring is the worst. I think I need to go to the immunologist or something and get those shots. Right, and remember, this could be any size array here. Size of question mark. We don't know how many they gave us. Yeah, we're going to compare them in a loop. Sure. So let's take the first one here. This is now the smallest. Okay, until we find a smaller one. And then we're going to loop through and we say, if we find a smaller one, is this one smaller? It's the new smallest. If this one's smaller, it's the new smallest. If this one's smaller, it's the new smallest. If this one's smaller, it's the new smallest. You got it, Zeeble. Hey, 10 bonus points for you, Zeeble. Okay, so we have a loop here. So we're going to say int smallest is my users numbers at index 0. Take the first value. Right, you must be the smallest one. And then we're going to loop. So for int, I'm just going to copy my loop here. Right? Then we can say if users numbers at the index is less than the smallest. If I find something that's smaller, well, I'm going to change smallest. Smallest must be this thing. right? If I found a smaller one, now I have the smallest. If it's not smaller, don't change smallest. And just loop on through. Okay, we can also do the same thing for biggest, right? Starts at the first one here. If I find a bigger one, if my user's number is bigger than my biggest, I have a new biggest. Right, biggest is that one we just found, which is biggest. How about an average? Well, total divided by the size. We need a total. Starts off at 0. Take total, we'll add to it user's number at index. Add the value. Okay? When we're all done, we can print out min plus the smallest. We can print out max plus the largest. Nope, biggest, sorry, biggest. And we can print out the average is the total divided by the length. User's numbers dot length. Right? That total we had, the running total, divided by how many there were. That's our average. Right? That's the definition of average. Right? Add them all up, divide by the number. Easy. Let's give it a shot. So let's enter our values. We'll do 7, 2, 21, 35, and 15. Why not? So let's enter 5 values. So 7, 2, 21, 35, or 25, and 15. Sure, why not? Let's see. Was the smallest 2? Bring it up a little bit here. Yeah, I think the smallest was 2. Was the max 25? Yeah, it looks like the max was 25. Average. Okay, let's add on. So 5 plus 7 is 12, plus 2 is 14, plus 21 is 35, plus 25 is 55, 60, plus 15, 75? 75 divided by... Is that right? I must have done some math wrong. Oh, no. I did it right. So the problem, what we got here, right? This is not 14. Oh, I'm sorry. Not 14. What did I do wrong here? Let's see. Because we had 5 values. 5 plus 7. I must have done some math wrong. Plus 2, plus 21, plus 25, plus 15. What is 75? 75 divided by 5 should be 15. We said the average was 14. We're doing some integer division here. But that should have added up. That's really weird. Why did it give me 14? That's really confusing. Huh. I'm going to print out total here for fun. Total. Let's try that again. So 5, 7, 2, 21, 25. Five numbers. 5, 7, 2, 21, 25. I was adding too many numbers, wasn't I? Yeah, 5 was the size. Was that my problem? I didn't actually enter a 5 last time, did I? What values did I enter? Man, I don't even remember. So 5 plus 7 plus 2 plus 21 plus 25. I got 60. How did I have 15 before? I don't think I had a 5 in there. That's the problem. Yep. All right, so my mistake. This first 5, I think I added to the last one here. Okay? So this is integer division, right? Because total is an integer and length is an integer. So we are truncating any decimal remainder here. Okay, the 15, yeah, I think I added a 5 in there. I don't remember. That's fine. But we were getting integer division, which is not what we want. So we can make total be a double if we wanted. If one of those is a double, remember we're going to get a decimal answer. We won't get integer division if one of them is a double. Let's try again. Let's enter 5 values. So what did I say? Oh, there we go. 7, 2, 21, 35, 15. 7, 2, 12. Oh man, my numbers are all off again. That's fine. 21 and 35. Why not? But now we see we get a decimal. That was the whole goal here, right? If we didn't have that, we were truncating our decimal remainder. So just be careful, right? All this stuff that from beginning of class comes back. Okay? But you see we can just loop through for every value. Okay. Now, if you wanted to, you could say, hey, we want to not have to do one extra piece of work. Sure. If you wanted to, and again, I don't really, I mean, at the scale we're doing things, we're not really all that concerned with efficiency. When you take data structures, 2353, we'll talk a whole lot about efficiency. But if we're starting with the first number here, and we're starting with the first number here, I don't need to start with the first number here. Right? What we could do is we could say, hey, total starts as the first thing, and then just go from 1. Again, I think that's awfully confusing, so I'm not going to bother. But you could if you wanted to, okay? Or you could say, hey, I already know what the first one was. Let's look at the next one. Start at index 1. I'm not going to bother. I think that just gets confusing, okay? So our array lets us get at all these values, okay? The cool thing here is what we can do is we can use, next is we can use an array list. So Java has this cool thing called an array list that's like an array, but it's smarter. Now, array list, we have to say of what type, and we use this greater than, less than notation signs for it, or angled brackets, I think some people call them. So we say, hey, I want an array list, and now I can't say int, okay? Sadly, you can't say int. You have to say capital I integer. We have to use the class name here. Don't worry too much about it. We'll talk more about it if you take 2151. But just know we can't be of type int. It has to be of type integer, capital I integer, the class name. And we'll call this, I don't know, a list of numbers equals a new array list. Array list of type integer. And then we give this one parentheses, because that is creating an object. So this is actually, when we talk about classes, we have to make a new instance. This calls the constructor here for our class, for array list. Okay, so now I have a list of numbers. Now, list of numbers, you don't have to give a size. Array lists can get bigger and smaller. We love array lists. Array lists can get bigger and smaller. We don't always make them smaller, but we could if we wanted to. It's easier to make them bigger, right? So we can say, I don't know, we'll have an int for number 0, sure, why not? And while number does not equal -1. Oops. Where do we find that scanner here? Let me bump this up here. Hey, math folks, welcome on in. We're having some fun with Java. Thanks so much for coming on by. You might be seeing an ad. I don't know if you get ads or not when you raid, but thanks so much for coming on by. All right, so with an array list, you can keep adding as much as you want. So we'll say enter a number or -1 to stop. Okay, we're going to assume like this kind of sentinel value, -1, we'll just say it's probably not a number they're going to enter. Most of the time when you ask for numbers, people give you positive numbers. So, oh, crow, those are some fighting words there. You have a chess mug? Oh man, I've got a chess mug too, boring math professor. Look at that, we got 2 math profs in the class now. This is exciting because we are doing some math. And if you stick around for another couple minutes, you'll see our next math-related project, which is super exciting. I always like doing math stuff. Anyway, this like -1 will be our sentinel value. We don't expect people to give us negative numbers. So sure, we'll probably be okay there. It is Sakaru's Bone Cloud mug. You are correct. GG, yo. All right, so we'll enter a number, and what you can do with an array list here, you say .add. We can add integer.parseInt of keyboard.nextLine. So they'll keep giving me numbers. I'm just going to keep adding. So array lists are infinitely resizable. Maybe not quite infinite. That's probably the wrong term. Eventually, your computer will run out of memory. But for our purposes, we can store millions of integers, and our computer won't cry. And if you are doing something with millions of integers, you've probably done something wrong in this class. Okay? We don't need anything that large. We're not doing anything at that scale. Hey, thanks so much for coming on by, BMP. Wait, let me give you a shout out here. I gotta figure out how to do this. I have to like copy your name here, so I don't have to type it. There we go. There we go. Look at that. And a shout out for Not Prof as well. All the math teachers. Uh-oh. I can't shout out twice in a row. I must have timed myself out. There we go. Thanks, Nightbot. Okay. And that's fine. So it doesn't like that I'm redefining number. That's okay. Let's take number out there. Now we can even just get rid of it. Yeah, some kind of cooldown. I'm learning all this cool Twitch stuff. I mostly just use it to share my screen because I like coding. All right. So we're just going to keep on adding some numbers. So then let's do the same process here. Find the min, the max, and the average. But let's go with the array list. So I'm going to grab all of this here. I'm going to copy all of it. Boom, 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 boom. To use the array list. So let's just redo here. We'll just reset smallest, reset biggest, and total. Now this is array list. What did I call that? Wow. List of numbers. There we go. Now with list of numbers, we still use index notation, but we don't use square braces. We say at. Nope, get. Sorry. We say get. You say get the index. So it's get notation. Still indexes here, but that's okay. List of numbers, get. And then list of numbers doesn't have a length property, it has a size property, or a size method. So it's ever so slightly different. So it's not array square brace notation. Use get for reading here. And we can call add here to add values. If you want to change a value here, let's go change all these here before I forget. So, gets. Get index here. Get the index. Get the index, and get the index, and get the index. Yeah, we haven't talked about the collections yet, Crow. We're doing things by hand. Just trying to practice getting used to working with arrays. Oops. This is list of numbers, dot size. Okay. We use get notation. If you want to set a particular value, you can say list of numbers, dot, and you have set. Now, set says which index here, so some index, and what value, new value. Right, so to change values, use set, index, and value. No worry, Crow, no worries. Okay, so we can get and we can set, but you can also add, which is super cool. So array lists are fantastic. I will strongly encourage everyone to use array lists for almost everything because they're just so much nicer because you can resize them. Okay, so let's try it. So throw out some numbers there in chat. What numbers should I add to my list of numbers here? You tell me. I'll enter the values. We'll see if we can find the min, the max, and the average. We'll make our computer do some maths. 3,947, 42. You're a good man there, Not Prof. You know the answer to the life, the universe, and everything. 1. Thanks, Fallen. 32,768, and that's probably good for now. We'll say -1. Uh-oh. Uh-oh. We never set number. My loop never ends. Oops. Number needs to be this thing before I add it. Oops, I broke it. So number needs to be set. Then I need to add numbers. So list of numbers, dot add the number. And now the problem is here, right? I also did a bad thing because I don't want to add the -1. If number does not equal -1, then let's add the number. Okay? So one of the problems with Sentinel values, you just got to make sure we're not doing the wrong thing with it here. Yeah, I'm going to recommend you always use array lists and not arrays. Okay? Definitely. Array lists are just much more flexible, which is nice. So let's try that again. Sorry, let me go back to those numbers you so kindly provided. 3,947, 42, 1, 32,768, 33, 10 to the 100 is too large for an integer. I'm sorry. So I'm just going to say -1. Stop. I know. Is that a 10 to the 100? That's not, yeah, that's a Google, right? And then a Googleplex is a 10 to the Google number of zeros. Is that how that works? I'm trying to remember. All right, anyway, let's enter some more values here. We'll just enter one of them. Let's say 1. So when we enter one value, great, done. We entered a bunch of values here, right, in our list of numbers. Did I give it a 1? I didn't give it a 1. Oh, I did give it a 1. Okay, we did give it a 1. Googleplex. Google, yeah, those are big numbers. I don't understand those numbers. They're too big for my head. All right, so we can get the min, the max, the total, the average, right, out of that as well. Okay? So again, we just need to get used to this syntax and play with it. We'll mention two-dimensional arrays on Wednesdays, Evil. We'll do more with them in 2151. So I'll talk about it briefly, but we're not going to do anything with them. Oh, yeah, when Google used to have a social networking platform. I think I was on that, right? I mean, like, everyone was auto-added because you had Gmail or something like that. You know what I really missed, though, was Google Wave. That was actually kind of cool. Google Wave was kind of neat. Okay, so let's talk about our next project. Right, we got a little bit of time here. Let me grab our assignments here. And I'm going to go grab it here. Need a new assignment. So we're going to use classes and we're going to use array lists. Right? Don't use arrays. Use array lists. This is project 4. Classes and array lists. Now this one's worth 25 points. Okay? So like I said, these projects get bigger and bigger and bigger. Create a new item inside of projects. Like that. Good. Due in 2 weeks here. April 5th. Okay? This will come up before you know it. So go to study group today. Start the project today, right at noon. Hop in on Zoom, meet each other, chat with each other, get started on this. So I have to like save it here before I can edit it. I don't know why D2L doesn't like me. And then I can go edit. Okay, there we go. Now I can edit stuff in the box here. I don't know why, but sure, that's how it works. Why not, right? All right. Boom. We're going to create a class called Big Integer. So please submit a link to your project in github.com. Okay? So what Big Integer is going to let us do is let us store very large integer values. The class is going to have a private array or array list of integers that stores the digits of the big int and a boolean to indicate whether or not it's positive or negative. We're going to add methods for add another big int, subtract another big int, and turn a big integer into string. We're also going to include unit tests that we talked about when we talked about classes to make sure we have 100% code coverage. So here's the deal with the big integer. Okay? It internally has some sort of way of storing all the digits. So remember the max number, the max integer in Java was 2 billion something. I know we have longs and other types that can get a little bit bigger, but say I wanted like the number 7,621,5,9,3,2,2,2,3,4,5,6,7,9,1,2,3,4,5,6,7,8. You can't see that because of my webcam, sorry. That's a really big number, right? That's thousands, that's millions, that's billions, that's trillions, quadrillions, centillions, sextillions, septillions, octillions, 7 nontillions? Is that a math word? Nontillion? Nontillion? I'm going to pretend it is. I'm going to just throw it out there like I know what I'm talking about. Okay? We can't store this in a Java number. It's too big. Right? But what we can do is we can store the individual digits in an array list here. Right? Throw all of those in an array list. Boom. Those are my digits. Okay? Is it nintillion? I don't know the proper term there. Help me out there, math profs. Or just smile and nod and agree with me so I don't look stupid. That's cool too. I like that. Just laugh at me in chat. It's all good. Feels good, man. Okay. So what I should be able to do is I should be able to take that number and add another number to it, or subtract another number from it. Right, so let's just look at some of these here. We'll just throw out some big ones here. So like 7, 3, 4, 5, 9. Here, well, let's just pretend this is one of them here. Is it nonillion? There's not a T? For some reason I thought there were T's there. Oh, I made that up. Nonillion. There we go. We fixed it. Thank you. Okay, so let's take one of these and let's take another one here. And let's say, I don't know, this is 1, 5, 7, 2, 8. Okay? Now, think back to math class. This is going to be an important piece here. Think back to math class. If I take this number and I add this number, does this number change? No, of course it doesn't change. Does this number change? No, of course it doesn't change. What you get back is you get back a new result. You get back a new thing here, right? And then think back to explaining this to your, second grader, third grader, how you start working with carrying numbers and things, right? You need to go to the ones place, right? You work from right to left when we add. So we go to the ones place and we add these together, right? What do we get? What's 9 plus 8? Well, that's 17. So 7, carry a 1. And then we go to the next place value. Add those together, add our carry. Yeah, we return a new value. Yep, so we're going to create a new big int. This is a new big int, right? So we get 8, there's no carry here, right? We get 11, there's a carry here. We get 9, there's no carry there. And we get 8. Look at that, folks. I can do arithmetic. So we get a new big int result back out. We did not change this one. We did not change this one, right? No change. No change. Okay? Is that Python? Is that a snake? Crow? I like it. Oh, PogChamp. We're doing arithmetic, right? Sure. So we can add these numbers together. Now, this gets a little bit trickier here, because remember, if these are array lists, right? This is index 0. This is index 1, index 2, index 3, index 4. What if we have numbers that aren't the same length? What if I want to add 379,251 plus 4,999? Right? If they're not the same length, they both don't have the same index. No, I'm sorry. I am totally backwards. That is not index 0. My goodness, folks. My brain is backwards here. I'm so sorry. Index 0 is on the left. Oh, goodness, right? Index 0 is over here. And then index 1, index 2, index 3, and index 4. Sorry. Yep. So this here is index 0, 1, 2, 3, 4, and 5. This one is index 0, 1, 2, and 3. Right? So we're not adding the same indexes together. We're adding the ones digit together, which is my size minus 1, right? Size minus 1 is your ones digit. That's your ones place. And then your next place, and your next place, and your next place. So what do we do? Well, sure, let's add these together. So 9 plus 1, right? 10, there's our carry. 15 and a carry. 12 and a carry. 14 and a carry. Well, if I don't have a value here, right, I could pretend it's 0. Sure, I could do that. So 8, pretend that was 0. 3. Okay? Ooh, length. You're talking Python there, not prof. Right, we could do it like this, right? So just make sure you fill in your zeros here, right? Okay? Now, some other fun things here. If you take a number, right, like 1, 2, 3, and you add a negative number, like 3, 4, 5, no worries. Python's all well and good. We're just talking Java today. It's okay. So if you add a negative, that's the same as subtracting, right? So that's 1, 2, 3, minus 3, 4, 5. Now, the problem is subtraction is actually kind of hard here. But let's be honest. Because what I need to do is I need to get a negative result back out. And oh, this gets a little awkward here. So my trick here for when you're subtracting, if your number is bigger, flip it. Say, okay, that's really 3, 4, 5 minus 1, 2, 3, and then the whole result becomes negative. Okay? I know that sounds silly, but this is a lot easier to do when we're not going to go negative with a subtraction result, because doing this is a little funny, right? Like, how do I take 5 away from 3? Well, okay, I can go borrow, right? That's a 1, that's a 13, now I have 8, and then I have 1 minus 4, I have to go borrow, I have 0, now I have 11, 11 minus 4, 7, and then 0 minus 3, negative 3. Right? That is not the right answer. That doesn't work, right? Like, you can't do that sort of arithmetic, right? This is no good. That's no good here. So we have to flip it. I'm so glad someone else did that, not Prof. That makes me feel so much better. So flip it. So 5 minus 3 we can do. 2, 4 minus 2 is 2, 3 minus 1 is 2, and then make the whole thing negative. So the answer then is negative 2, 2, 2. Sorry, that's behind my face though, isn't it? Right? So flip it. So if you're subtracting, you need to make sure that the larger number is being subtracted, the smaller number is being subtracted from the larger. So it's larger minus the smaller. Okay? Yeah, we don't get to the binary 2 complement or anything like that, Pandemic Watch. That is super fun stuff, but we're not at that level yet. We're just trying to work with Arraylists and classes here. Okay, so that is a number minus another number. You need to find the largest. Okay? If you have a negative plus a number, so like negative 2, 3, 4 plus 123, right? Well, really, that's the same thing we were doing before, right? It's really one number minus another. We need to find the bigger and subtract the smaller and make the answer negative. Right? So it's bigger minus smaller. And then it's negative if bigger is negative. If the smaller is negative, then we just leave it alone, right? We'll have a positive answer. So there's a funny case there, okay? If you have a negative number, like 2, 3, 4, minus a negative, 1, 2, 3, remember, minus a negative is just a plus, okay? And we know how to do a negative number plus a number, right? We could do that one. So we can do those different cases, right? So you might have plus and plus, you might have plus and minus, or plus a minus, you might have plus and actually minus, right? You might have a plus and minus a minus, right? We got all these different ways of having all these numbers there. We just need to simplify it, right? Adding is easy, okay? Subtracting is easy if the bigger subtracted, the smaller subtracted from the bigger, right? So the idea there is we're going to have our class. Yeah, yep. Take the difference, right, and apply the negative, definitely. Okay, so we're going to have our class there. So a big int dot add other big int other. Sorry, that looks terrible there. Let me come back to some code here. Right, so let's start up here. This is project 4. Okay, so we're going to add a new class here. So not here in main. A new class, big int. Okay, so big int will have a method here, public, that returns a big int. Add a big int other. Right, it'll do something. Do something. Right, we'll have a public big int subtract a big int other. Right, do something. We're also going to have a public string method called toString. And this is return a nicely formatted string with thousands separator. Like 1 to 12,345,678. Sure. Or with a negative, right? Sure, negative or not. Okay, so we add a big int. Our big int doesn't change. and the other big int doesn't change. We make a new big int, right? Do not change itself or the other. Turn a new big int. Okay? Do not change. Do no change. My Yoda. Do not change. There we go. Okay? So we're going to tell Java we're going to figure out how we can do arithmetic with really large numbers. Okay? We got to find where we start here. There's somewhere. There we go. We have to look for the indexes, right? Find the index values, and then add them up or subtract, right? We have to figure out adding, we have to figure out subtracting, and really the different combinations of positive and negative, we just need to figure out which way it actually needs to go, right? Adding a positive, adding a negative is just subtraction. Subtracting a negative is just adding. When you subtract the number, find the bigger, subtract the smaller, and then figure out if it needs to be positive or negative, right? And then that toString. And we need unit tests, right? The whole idea with unit tests is, right, if I give it this example, then I know what I should get back out. Oh, I didn't hit save yet. I'm sorry. Look at that. Save and close. Now you'll be able to see it. Sorry about that. Okay, I'll add a rubric in just a little bit for you folks. We are about out of time here. Go to study group in 5 minutes. Right? Go to study group and chat. Think about ways you can approach this. Okay? Like, please don't just start writing code. You're going to be in a world of hurt if you just start jumping into code. What you want to do is you want to get the steps out, get your process down, that pseudocode, figure out, well, what do I need to do? What do I have to check for? You know, what am I going to look at? What steps am I going to do in English before you start writing the code to make sure that you can sanity check yourself? Because we can check real quick, like do some numbers here. And that's what the unit testing is all about. We're going to do some unit tests to make sure we get 100% code coverage, that every if block is tested, every else block is tested, right, to write our unit tests. Remember, so you're going to need more than one test. For now, just to make this compile, I'm going to say return new big int. This is totally incorrect, but I just wanted to be able to compile here. Okay, and most of the time, this toString is going to be what's easiest to test. We can just check what gets toStringed back out. Right, to get tests, you right-click, go to navigate, go to test, leave it, make sure it's JUnit 4 here, and we're good to go. And we're going to have a bunch of different cases, right? We're going to test a bunch of things. So test like add two positives. We're going to test add positive and negative. We're going to test, on and on and on and on. All the different cases that we have in our code, we need to have tests for. Test numbers that have different lengths, right? Test add big ints, or add ints of different sizes, right? Can I take a two integer value big int and like a 7 value big int and make sure I don't mess up the values, the place values, right? That sort of thing. All right, so we commit this code for you. So this is chapter 7 and project 4 starters. This one is going to take a lot of thinking, right? Go to study group, talk with each other, think through it. Think about your steps before you just start writing the code. Solution is actually not that hard, I promise. Right? Once you get the steps down, it's not so bad. Right? But there's a lot of thinking involved in what do I have to do in this case? What do I have to do in this case? What do I have to do in this case? And we're going to work smarter and not harder. Okay? Be a good lazy programmer. Okay? And don't do more work than you need to. All right? Questions, thoughts, concerns? We'll talk more on Wednesday about arrays, array lists, and we'll talk more about big int if you have other questions. And we can go from there. Smarter, not harder, not with a silent K. I love it. I love it. So let's see who else is around on Twitch. We can send a raid out, and then you folks can go to study group in 3 minutes. Don't forget you get a bonus point on your quiz just for attending study group. Right? Like, how cool is that? Ooh, let's check out Professor EXP. I think, yeah, Gath doesn't allow us to raid, so we'll check out Professor EXP. Head over that way. EXP. Here we go. Formerly an OCC professor, which I learned, which is pretty cool. So we'll go hover that way. You folks say hi. Take care. Thanks so much for hanging out. I've got office hours today, briefly, 1 to 2. I have them tomorrow. I have them Wednesday, and then a little bit Thursday on my busy day. So reach out. Let me know if you have questions, thoughts, concerns. If not, I'll see you folks on Wednesday.
Together.